All right, good morning, everyone. Whether you are at home or in person, I'm glad that you're joining me today. We're going to do a Unit 3 review for Algebra 2, which is all about sequences and series. So how today is going to work is we're pretty much going to spend the first 10 minutes or so with direct instruction, me walking you through a few examples, and then the bulk of the class, probably the last 20 to 30 minutes, is going to be you guys working on a practice test. So I'm really grateful if you can be here in person, then you guys get to work in teams on it, which kind of makes it a little easier. But if you're at home, you can still earn the same 10 points for today by doing your practice test. So let's kind of jump right in with a couple examples. Hopefully you have the notes printed out. I know anytime you show up in person, I give you a copy of those notes. But it's just basically what it does is it takes all of the slides and it gives you places to write on them. So we're not spending our time copying everything down. So for week 11, you are going to submit your 9 answers from the practice test to the Dropbox. So if you're in person today, you're going to do those 9 questions together in teams. If you're at home, you're going to do those 9 questions on your own and submit those to the Dropbox. And that will give you your 10 points for week 11. So it's not really an essential question. It's more just really good practice for your test this week. So here we're going to do a quick warm-up. These are what we stopped with last time. So I'm going to set the timer, give you guys a minute or two just to start working on them. If number 1 kind of throws you off, try number 2. They're sort of, they're different types of questions. So let me put up the timer for a minute and let's just try 1 or 2 of these as a warm-up. All right, so even if you didn't get through all 3, that's fine. This is just called a warm-up. We're going to start with 2 and 3 and come back to number 1. So number 2, if it says find the 6th term, where do I plug in a 6? Everybody says n. Yep, you're just going to put it where you see your n. So for my 6th term, it's going to be 21 plus 5 times 6, which would be 21 plus 30. So my answer, 51. Please don't miss those on the test. You will have ones that look just like that. It will tell you what term to use, and we know that in my formula, n stands for the number of the term. So that means number 3 is very similar. It says find the 4th term, and hopefully on your notes you're kind of doing what I do. I call it marking up the text. I'm circling any kind of important pieces of information. I like to draw arrows for myself, showing myself where am I going to put the 4. So just like on number 2, we're going to put it where we see the n. This would be 5 times 1/2 to the 4 minus 1. So all I have to do is order of operations. So out of all those things, I have to do my exponents first. So my exponents say 4 minus 1, which should give me a 3. Everyone okay with that step? Exponents first. Now out of what I have left, am I going to multiply my 5 and my 1/2, or do I have to do my exponent? What do we think? Exponent. Yep, you guys are right. So watch what I'm going to do. If you're like, I don't know what 1/2 to the 3rd is. Remember what our powers mean. It really means me writing it out that many times. So all I have to do is go straight across the top, straight across the bottom. So I'm going to get 1 divided by 2 times 2, 4, 4 times 2, 8. Is everybody okay with how I did that? I just wrote it out, and then you multiply across the top, across the bottom. So that's not my final answer yet. That was just the 1/2 to the 3rd power. So I still have a 5 times my 1/8. How can I fix my whole number out in front though? Meaning, because it's kind of weird to multiply a whole number by a fraction. What can I do to my whole number? Exactly, put a 1 under it. So now when I go straight across the top, straight across the bottom, my answer is 5/8. Did that one go okay after we walked through it? So anytime I give you the number of the term, you just plug it in for n number of terms, n number of terms. Number 1 is still kind of the same. It's not that tricky. It's giving us this formula, and it's saying find the first 3 terms. So over on the side, I know you guys have more space than I do. That means I want to know what A1, A2, and A3 equals. You guys would agree that's the first 3 terms, right? A1, A2, 1, it tells me is 400. Well, that's handy. I only have 2 more to go. Then it gives me this formula over here. So I already know A1. I don't need to find A1. So which one do I need to find next? A2. Good. A2. So that means my n this time is going to be a 2. Here's why. I'm finding A2, so my 2, it goes in place of the n. So I'm really finding A2. Watch what happens when I write in A2 right there. So I say square root of A2 minus 1. What's 2 minus 1? 1. So this, my answer is really going to be the square root of A1. And what's A1? 400. So I need to know what the square root of 400 is. What times what? Anybody know? What times itself is 400? Watch this. If I cover this section up. Well, almost. What's the square root of 4? 2. So, and then what's the square root? I know I have 2 zeros there, so that's kind of like 100. Square root of 100 is 10. So it's really like 2 times 10, or 20. So 20 times 20. So my A2 was a 20. Now I'm going to try it again, same formula. So here's my formula, but this time I need to find A3. So my n is going to become a 3 this time. So this one, let me just give myself space at the bottom here. Much better. Okay, so this time we're trying to find A3, which means this is 3 minus 1. 3 minus 1 is 2. So I'm really asking myself, what's the square root of A2? Well, let's look back up there. A2 is 20, so I need the square root of 20. Does that come out perfectly? Is it something times itself perfectly? No. So we could say square root of 20, or on a test they also might make it into a factor tree. 4 times 5. So instead of saying square root of 4 times 5, you can take the square root of 4. What's the square root of 4? 2. So 2 root 5 would be your other answer. That we did those a long time ago, but it's been a while, so I'm just refreshing your memory. So if it asks you, what's the 10th term, you're going to plug in 10. If it asks you, what are the first 3 terms, you're going to write out A1, A2, A3, and you're just going to solve for them. So you guys did great. That was all from last week. On your paper, and Cletus, I did K-mail this out, so if you haven't printed it yet, make sure you go to your K-mail and print this. Everybody in the room has a copy. The top part of your worksheet says sequences, right? Top part of our worksheet is sequences. And then the bottom portion is your series. So sequences, we have arithmetic and geometric. So we might have made some notes on our paper already. Hopefully we have. It's going to be arithmetic if, what's the rule? It is multiplied or, added or subtracted. It's geometric if it is multiplied or divided. Good job. We have a recursive rule, which you always have to know the previous term, so make sure this part is circled on your notes and you have written in that that's your previous term. Then we've always had a really big star by iterative rule, because iterative rule is way more useful. So please make sure your notes sort of look like mine. Next to arithmetic, add, subtract. Next to geometric, multiply, divide. What does this a to the n minus 1 mean? That always means your previous term, means the term right before it. And then we put a star by iterative rule because it's much more useful to us. So that's our sequences section of our notes. Then we have a series section of your notes. There's slightly different formulas. Let's do the same thing. So next to arithmetic, let's put add, subtract. Next to geometric, let's put multiply, divide. Again, which one's more useful? 99% of the time, well actually, these don't have iterative and recursive rules. See how they kind of say, they're giving you different rules at the top. We're going to be working with these today. So this one is if you know the first and the last term. We can kind of write that in. Let's circle a sub n, and let's put that that's your last term. And then we can use this right-hand column no matter what, so anytime. So our right-hand column, all the way down our page, we can use anywhere, anytime, always. The left-hand side is only if we have certain situations, only if we're given certain key pieces of information. So we're going to practice this today, knowing when to use which one. It will be part of our practice test. So we're going to try a few. I'm giving you 3 different. Now, let me ask you, are these sequences or series, and why? These 3, Alex, are sequences. Why? Because they have commas and they go dot, dot, dot. They keep going and going and going. These are sequences. What makes something a series? Yes, if it's a series, they'd have addition signs between them. Great job. Everybody okay with the difference? If we want to come back to our chart, this would be great. If we go next to sequences, let's do an example. Let's say 1, 3, 5, 7, dot, 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 dot. That's a sequence. I'm giving us an example next to sequence. What makes something a series? If it has addition signs in it. And what else was interesting about series that we learned last week is that there's an ending. See how it ends at 7? It doesn't have the dot, dot, dot in there. It will always give you the ending. Or it will say find the sum of the first 12 terms, like you're talking about a specific amount of terms. Okay, great. So here we go. This is going to be great practice for us today. 4 pieces to the puzzle. Decide whether it is arithmetic, geometric, or neither. So we're going to stop and we're going to do part A for all 3 of my options. So let's look at part A. Let's look at number 1. It goes from 1 to 9 to 17 to 25. So obviously it's getting bigger. So you need to ask yourself, is something adding going on each time? Is it a multiply going on each time? How are they getting from one to the next, one to the next? So think about that. Okay, there's only 2 options if it's getting bigger, right? It's either going to be adding or it's going to be multiply. So let's try both. I could say, well, that's multiplied by 9. Is that one multiplied by 9? From 9 to 17, is 9 times 9 17? No, so that pattern does not hold true. Let's try an addition model and let's see if that holds true. From 1 to 9, you are adding 8. From 9 to 17, did you add 8? Ah, we found it. See? You have to try both. So we're looking at our numbers and we're saying, okay, it's getting bigger from one to the next, one to the next. But does that mean it's multiplying or does that mean it's adding? So we tried both. The multiply didn't work. It worked the first time, but it didn't work the second time. Adding 8 works the whole way through. 17 plus 8, 25. So we get the idea. We found it. So what kind of sequence is this? Arithmetic, geometric, or neither? Arithmetic. Perfect. Add that to our notes. B said, find the common difference or the common ratio. So in this case, arithmetic always goes with common difference. So the difference is 8. Let's write the next term in the sequence. So if we're at 25, everybody please write your next term. What did we get? 33. Everybody okay? So that would be my A5, A sub 5 term. Are you okay with me writing it like that? So my A1, A2, A3, A4. So my A5 term would be 33. And then lastly, we're going to write the iterative rule. So go back to your notes. Grab, I don't even have mine. Let me get a paper. So we're saying this is an arithmetic sequence, so everybody should be looking at the top part of their notes, right? Arithmetic sequence, and it wants the iterative rule. So we should all be looking in the right-hand column under iterative rule. So what's the formula? A1 plus n minus 1 times d. Is everybody seeing the formula that I'm looking at? Upper right corner? So we need to fill this in. My A1 just means your very first term. So everyone look at your sequence. Your very first term is A1. Good job. Plus the n stays n. And then we found my D. What did we say our D was? D was 8. Fabulous. You're almost done. Who remembers how we finished this off from last week? How do I finish this equation?
Put together the two common terms.
I do have to put together my common terms, but in order to do that, I have to distribute. I have to distribute the 8 first, because that's the multiply problem over there. So that's 8n minus 8. So your final formula will be 8n minus 7. That is the formula that represents that sequence. It's really nice when they give us the formula, but they don't always, right? Sometimes they're going to make us write it. And when we do, it's really not that bad. You guys did a great job. Questions on any of the steps so far? A1, first term. D, we already found that. That was 8, the difference between the terms. Okay, good job. Let's try number 2. Just giving myself some more space here. Okay, number 2. Decide whether it's arithmetic, geometric, or neither. So we're seeing that it's getting, what is it getting? Is it getting bigger or smaller? We start with 1 out of 18 and we're getting all the way to 1/2. Would you rather have 1/18 of a pie or half of a pie to eat? Which one's bigger? Half. So it is still getting bigger. So they're fractions, but they are still getting bigger. So the question is, what's going on there? Are they adding something together or are they multiplying something together? I'm not so sure. Kind of hard to tell. So when we can't tell, the lesson gave us a really good way how we can find it ourselves. The way that we can find it ourselves is you take one of the terms. I'm going to take my 1/6, and you subtract from the term in front of it. Or you take the term and you divide by the term in front of it. We have to try both, because if we can't see it ourselves, we have to try both. So this one, in order to subtract, I'd have to get common denominators. So I'll just do that for you really fast so that you can see. So this would need to be an 18. So times 3 times 3. So 3 over 18 minus 1 over 18 gives me 2 over 18. So for subtracting purposes, what happened from here to here is it actually added 2 over 18. It would also have to add 2 over 18 for my next portion for that to also be true. So I'd have to check it again. Meaning I'd have to do 1/2 minus 1/6. So if I make that a 6 times 3 times 3, so I would get 2 over 6. So is 2 over the 6 the same as 2 over 18? No. So it did not add anything to get your pattern to hold true. So now we have to try this division one. I know it looks crazy scary with these fractions, but does anyone remember how to divide this bottom fraction down here? Not as bad as it first seems. Times by the reciprocal. So I get 18 over 6, which is 3. So they're saying that how they got from 1 over 18 to 1 over 6 is they times by 3. Let's try from 1/6 to 1/2. Let's see if they also multiplied by 3. So I'm going to do my 1/2 divided by 1/6. Which really means multiply by the reciprocal, and I get 6 over 2, which is 3. Oh, I found one. Thank goodness I found one. I'm going to give you guys a quick hint, though. because I know that sometimes dividing fractions looks really, really scary. So here is a really good hint. Watch if I look at it backwards. Look at this. How'd they go from 2 to 6? By 3. How'd they go from 6 to 18? Times by 3. Same thing. So I want you to know that this is the way the book teaches you to do it, but intuitively we can sort of look at just the denominators and find it ourselves. So does the book's way always work? Yes, but it's a little scary. So we're always going to be looking for our own patterns, and we found it. And we definitely found it. So my pattern was times by 3, which means if it's multiplied by 3, what kind of sequence is it? Is it arithmetic or geometric? So geometric. And we said find the common difference or common ratio. So the common ratio would be a 3. So difference always goes with arithmetic. Ratio always goes with geometric. Please write the next term in the sequence. So can you guys multiply the 1/2 by 3? And let's get the next term in my sequence. How do I do 1/2 times 3? Make the 3 a fraction. Go across the top, across the bottom. We can say 3 over 2. Or we could say, how else could we say it? 1/2. Okay, good job. Now it says write the iterative rule. So everybody go back to your formula sheet. I want you to look under geometric. We're at the top under sequences and iterative rule. We should see that it says A1, A sub 1, R to the n minus 1. We're under geometric, still looking at iterative rule. So let's fill in what we have now. So my a sub 1 is your first term in the sequence. That's a 1 over 18. 1/18. My r that we just found is a 3 and minus 1. And we are done. We're done. Am I allowed to multiply the 1 over 18 times 3? Yes or no? No is the answer. Good job, Taylor. Can't multiply those two because you always have to do your exponents first. So I'd have to do 3 to the whatever this power is first, then multiply by my 1 over 18 at the end. So that's my answer. So now we're going to get into the tech series and sequences that you guys had. I think it was 3.12. And we're going to use some spreadsheets. Okay, take a deep breath. This is not on the test. Yay, not on the test, but you still have a quiz on it. So we're going to practice together with one problem, and you're going to see how easy it is. It's so super easy to use. So what's great about spreadsheets is that they can do all of these sequence stuff for you, which is pretty fabulous, I have to say, once you get to using them. My husband works in the bond market in Newport Beach, so he is like an Excel king. Like he works in Excel all day. That's all he does. So in this example, we want to find the first 6 terms for this geometric sequence using a spreadsheet. So before I have you guys go on the computers for a moment and try this, I want to know how would I type this formula into Excel? So let's think about that. How would I type this formula into Excel? I want you to recognize 2 key pieces of the puzzle. What is a multiply symbol going to look like in Excel? And how are you going to do an exponent in Excel? So let's talk about those 2 things really fast. So in Excel, I'm going to have my 4. Has anybody ever tried to type a multiply symbol into Excel? Do we know what it looks like? It's like an asterisk, exactly. So can you add that to your notes? It's going to end up looking like an asterisk. Then we have our 2. How do you show an exponent using Excel? Anybody know?
I think it's a control command.
It is a control command. It's actually right above the number 6. I'm going to put this down here for you. It's right above the number 6. It's a little caret. We call it a caret. So to make it execute, you're going to go Shift 6 or Control 6, and it inserts this little caret. which means it's making the rest of it an exponent. And then the last part, I need the n minus 1, but I need that whole thing to be an exponent. So the way that you're going to tell the computer to make that whole thing an exponent is by putting it in parentheses, just like that. So on a quiz, how this will look for you, because the quiz is not going to force you to use Excel, the quiz is going to say, which one of my 4 options shows the correct way I would type it into Excel? And one might be like this. Do you guys see the difference? They're checking to see if you know if it says 4 times 2 that the times is going to become an asterisk. And if it says raised to the n minus 1 that that's where the caret's going to go. Do you guys see the difference between A and B? That's how they're going to quiz you on this stuff because I checked out the quiz before I prepared this lesson. So I wanted to make sure everybody sort of knew the difference. So what is super cool about Excel is it's going to give you the answer. So here's how it's going to look. I'm going to send you to try it in a second. Under column A, you're going to put the numbers that we want to plug into my formula. So why did I pick 1 through 6? Because what did my question ask me? The first 6 terms. Okay, so if it says first 6 terms, you are going to plug in 1 through 6 into column A. Everybody good with column A? If I say first 10 terms, you'll type 1 through 10. Then in column B, this is where your formula goes. Column B is where the formula goes. And you have this in your notes, right? I gave you this slide. Okay, so in column B, what's my formula? We looking at our notes there? Okay. To use a formula in Excel, you always start with an equal sign. Always. And then look what I did. I did exactly what we just wrote out on our paper. 4 asterisk 2. 4 asterisk 2 raised to the, now instead of putting n minus 1, I put A1. Can somebody think about why I put A1? Look at what's in A1. Look what's in box A1. The first number I wanted it to plug in. Does that make sense? So instead of saying n, our n is really a 1, but how do you make it do 1? You tell it to type in this box. Let's think about what my next box would be. Can you guys try writing it on your paper with me? So for B2, I'm right here in this highlighted space. I know you guys don't have as much room as I do to write, but just draw a line with the little arrow. It's going to start with an equal sign, because they always do. You will do your 4 asterisk 2 caret. Now, which term do I need to grab now for it to say minus 1? A2, great job. Because now you wanted to grab the 2 instead. Can you guys write one more out by hand and then we'll try it on the computer? So try B3. Fill in box B3. What will the formula be right there? So it's not so scary. Looks scary, but it's really not that bad. So we're going to have 4 times 2 caret, oops, not an A, missed a 3, caret. What goes next? A3 minus 1. So we're going to hop on the computers really fast, try out this formula. I want to see what numbers are you going to get to complete box B. Because what's cool, see how my first box has a 4? I know I have it hidden now. My first box has a 4. After I typed in that formula and I hit enter, it gave me the answer. So cool. So after you type in B and you hit enter, guess what's going to pop up there? The answer. Kind of neat. If I hover over B1, which is what I'm doing in my example here, I put my mouse back over B1, it still gives you your formula in the box up here. So your formula has not disappeared. It is just executing your formula and putting your answer down there. It's really neat, really nifty. So we're going to try to figure out boxes 1 through 6 using Excel. And then after we are done with that, all that we have left to do is to take your practice test and submit your 9 answers to the Dropbox. So the people who are here in person are going to work in pairs. Your worksheet does have these problems in them. And so I'll quickly scroll through them for those people at home who need to, oops, except mine has the answers. your example doesn't have the answers, so actually I'm not going to continue on and show you my questions. You will need to print out the notes that I gave you, that way you have the questions. All right, so if there are not any questions, please make sure that you try the Excel, see what answers you get for right here, and then print off my worksheet or open the worksheet so that you can see the 9 questions that you need to submit to the Dropbox for your 10 points today. All right, thanks guys. Have a great day. Okay, I went back through the test and I just hid all the answers. So here are your 9 questions. I'm going to go through these pretty quickly for those of you at home, but again, they are on the notes page for you to look at, and you can pause at any time while you pause, rewind, since it's a video, you know, all those good things. Here's number 2. Number 3. Number 4. Number 5. Number 6, which I have the question covered up, so that's really good. There we go. Number 6. Number 7. Number 8. And number 9. Okay, so again, these are in your notes that you can print out to use, or when you're watching the video, you can always pause and rewind. Thanks, guys. This goes in the Dropbox for week 11.